Hello, Professor. This is Jayant, and I'm going to show my demonstration of Hackathon for time series forecasting. My team is Alpha Devs, and my teammates are Shubham Kotia and Manada. The first step is data preparation. Here, we use different multiple data sets covering agriculture and climate for India from 1961 to 2022. We load the four data sets: fertilizers, emissions, crops, and climate, which contains fertilizer, emissions, yield, and climate data like precipitation and temperature. And then we combine all these data sets by the common year field to create a continuous time series. Uh, we then add climate data to bring essential factors that might affect the yield, like precipitation and temperature. And finally, we output it as a CSV file. And we can see all the variables. And then the second step is EDA, exploratory data analysis. So here we'll address any missing values, or we'll find any relationship between variables. So this helps us understand the data better. So for handling missing values to ensure the consistency, we did forward and backward fill missing data points by carrying the forward or backward the previous values, and then used in linear interpolation to to further fill any remaining gaps based on the adjacent values. So why we need to do this is it keeps our time series data smooth and complete. And then we'll just look at the summary statistics. It basically gives us the insights of each variable, like average and temperature. So next we visualize the data. This is the temperature trend plot. So it shows any temperature changes over time which affect crop yields. And then this is a correlation map, heat map, to highlight the relationships of variables. And step three is feature engineering. Here we enhance the data set like by creating new features. So first is temperature deviation. That is, we calculate the difference between max and min temperatures, which is called a temperature division deviation new feature. So this captures the temperature swings, the changes which impact the growth and crop growth. Next is rolling precipitation. So what we do is we create a 3-year rolling average. So this shows broader trends, helping the model understand the effects of long-term effects of climate on agriculture. And the next is lag yield. So we had a lag yield feature uh, by taking the yield from the previous year. So why we do this is we allow the model to consider the past yields while making present predictions. So these new features they help in climate variability, long-term precipitation trends, so which are helpful for forecasting. And the step four is like model selection and training. So here we used AutoGluon, a framework used for model. I mean, it abstracts all the data preparation, I mean, pre-processing, fine tuning, and like model selection, etc. So we used AutoGluon's tabular predictor that automatically trains and tunes multiple models based on the type of the data we have. So it automatically searches for the best possible model that fits our data. So I install AutoGluon here, and then we evaluated the models based on root mean square error, and the metric used is root mean square error. AutoGluon automatically tests various models and ranks them. So we can see using its leaderboard function, we can see what all the models it has trained and the best performing model as well. From this, we can observe that the weighted ensemble L2 is the best performing model, as it has the least score underscore val. That means the lower the negative value, higher the accuracy. So, and the last step is model evaluation. So we evaluate the performance. So what we did was you normally we didn't have a new data, so we just did on the test data itself and we got some predictions. And then we plotted we generated a feature importance metric so we identified which features are the most important ones that affect the yield, and we can see the scores of them. So you can see production is pretty much important as well as nitrogen. The rest of them follows. So these help us in identifying the most important uh, factors that affect the yield. So we are allowing us to focus on key factors that influence the productivity. So this is our time series forecasting model. Thank you.